This presentation is on calculating variance and standard deviation. We will learn the formulas for variance and standard deviation, understand better how they operate, and work through an example from the world of social science. Variance is a key component of what social scientists seek as they analyze puzzling phenomena. It is basically a prerequisite for quantitative analysis. We contrast variance to a concept called the constant. One cannot explain a constant, famously expounded the philosopher John Stuart Mill. The sun rises in the east. It just is. Variable phenomena, in contrast, can have their variance explained due to various plausible hypothesized factors. Hence, we need to have a good way to capture the extent to which variables vary. The formula for variance starts with the idea that we need some orienting anchor for determining the extent of the variance. We can start with looking at how much a variable varies based on its mean value. Then we can summarize that variation and further account for that variation based on the size of our sample. The formula for variance is as follows. Variance is the summation of deviations around the mean value that are squared divided by the total number of cases minus 1. Again, we calculate for each case the deviation from the mean value. We summarize each deviation from the mean value. We then summarize the deviations from the mean value and divide that summation by the total number of cases minus 1. In our example, we have 10 countries as listed in the first column and the number of years that they have been democratic over the past decade in the second column. In the third column, we see that each observation is subtracted from the mean value. We could try summing up those deviations from the mean value, but the summation would yield an answer of 0 at the bottom of the third column, which would imply that overall there wasn't much variation in the deviations from the mean value, a totally misleading result. Instead, to capture the fact that positive and negative deviations cancel each other out, which is why they sum to 0, we square each deviation from the mean value and sum those squared deviations. We can see what happens when we do that in the last column. The sum of those squared deviations is 54. If we follow the formula, we will then divide the sum by the total number of cases minus 1, accounting for the fact that we are using a sample of the total number of countries in the world. And our conclusion is thus compromised because we don't have perfect information, called degrees of freedom. The variance is the result of this division, and in our example is equal to 6. The formula for standard deviation is as follows. In essence, it is the square root of the variance. Looking back at our example, the standard deviation is the square root of the variance and is equal to 2.45. Which is more correct? It's a trick question, as both variance and standard deviation are correct. We calculate both values. However, we frequently use standard deviation instead of variance because the variance numbers can be quite high. Standard deviation equates more closely with the actual variation of the range of values for the variable. In our example, the variation of values seems closer to the standard deviation than to the variance. In other words, the standard deviation seems more correct in eyeballing each deviation from the mean value. This is how we calculate variance and standard deviation.